Next important concept in managerial decision making is payback period, which is essentially how long it takes your company to get its initial investment back on anything it chooses to invest in. So in this case, we have Wilmer Glue Company, and they are considering investing in 3 different capital projects. The initial investment of all 3 is $1 million. We're going to use the expected annual cash flows provided in this table to determine the payback period for each project. Based upon payback period alone, which project is most desirable and which project should be removed from consideration. So let's go through and figure this out. For project A, we have accumulated. After year 1, where we have a cash flow of $125,000, we're going to have a total of $125,000 cash. In year 2, we're going to have the $125,000 that we had from year 1 plus our annual cash inflow for year 2 of another $125,000, bringing our total to $250,000. At this point, we can just fill handle this formula on down. And we see that after year 3, project A will have given us $375,000 in cash inflows. After year 4, $500,000. Year 5, $625,000. Year 6, $750,000. Year 7, $875,000. And year 8, $1 million. Well, conveniently, $1 million, as it says up on top, is the initial investment for all 3 projects. So how long does it take Wilmer Glue Company to get its initial investment back on project A? It takes a total of 8 years, so we can just fill in 8. For project B, again, our accumulated in year 1 is going to be equal to our annual cash flow from that year, and in year 2 it's going to be equal to our previous accumulated balance plus that year's cash flow. So they'll have $500,000 for year 3, and we can fill handle here. In year 2, they had $500,000 plus year 3 cash flows of $400,000, giving them a total of $900,000. And in year 4, they had $900,000 plus $500,000, $1,400,000. We know we need to figure out the point where Wilmer Glue Company gets its initial $1 million investment back, and we can see from our accumulated cash inflows that it's somewhere after year 3 ends, during year 4, but before the end of year 4. So to figure this out, what we can do is we can come down to payback, we can hit equals, and we can type in 3 because we know we're going to need 3 years, plus the portion of year 4 that we're going to have to go through in order to get that additional amount we need to get to that $1 million. So after year 3, we had $900,000 in accumulated cash flows. We need to get to $1 million, so simple math right here says that we need to get $100,000. If we take that $100,000 we need to get from the $900,000 in cash flows back to our initial investment of $1 million, we're going to divide that by the $500,000 in cash flows we had for year 4. So 3 plus 100,000 divided by D9, which is the cell for our annual cash inflows from year 4, and it comes out to 3.2 once we move this decimal over. It takes 3.2 years for them to get their initial investment back on project B. Let's move on to project C. Same concept here. In year 1, our accumulated cash flows are just year 1's cash inflows. In year 2, they are equal to the accumulated balance from the year before plus that year's balance. And we can scroll down all the way like we did before. And we got a conundrum here with project C. As you can see from our accumulated cash flows, it only gets to $900,000, which is an issue because how much did we invest to start with? We invested $1 million. So at what point will Wilmer Glue Company get paid back on its initial investment? They won't. So project C can just get removed from consideration because it's not going to make back what our initial investment is. No one's going to shell out $1 million to make $900,000 over the course of, in this case, 6 years. So that project, completely undesirable, should be completely removed from consideration. The project, at least by NPV or by payback, that is most desirable is project B because it only takes 3.2 years to get our money back. The next method we can use to determine what is the best investment out of our alternatives is the net present value, or NPV method. This determines the return that you're going to get on your investment when you discount your future cash flows for the time value of money, for how long in the future it's going to take to collect them. In this case, ABC Corporation has $1 million in available capital, and the company has identified 3 potential projects to finance with this capital. ABC Corporation requires a 14% rate of return on all investments, and they're going to use the expected cash flows listed here to determine which projects they should finance, if any. I'm actually going to start with Project B because it has regular cash flows. It's $55,000 every year, unlike Project A where it differs every year. So it makes it much easier when you have that regular stream. For the present value of cash flows, you can go in and you can use your present value of an annuity table to figure out the factor for what it's going to be. But the easier method, at least in my opinion, is to let Excel do the work. And to let Excel do the work, you're going to use the present value method. So we're going to go into insert function, the little f of x symbol up here. We're going to click on PV, and it's going to bring up the screen where we can fill in our function arguments, as they call them. So for rate, that is the required rate of return that we need to discount by. And for this company, it is 14%, so we're going to type in 0.14. NPER is the number of periods that project is going to provide future cash flows for, and in the case of Project B, it is 7 years, so we're going to fill in 7. And PMT is the amount of each payment that they're going to receive. And in the case of Project B, that is $55,000 a year. So with those 3 inputs put in there, we're going to hit OK, and we're going to find out that our present value of cash inflows is $235,856.77. Excel, for whatever reason, always puts this as a negative, so you can go up to your formula bar up here on the top, and between your equal sign and the P and PV, just put in a negative symbol, and it'll turn it to be positive. The initial investment for Project B is the $285,000 that we have listed here. So we're just going to hit equals and click on that cell and then hit enter. The net present value of Project B is equal to the present value of cash inflows minus the initial investment. And as we see here, it is negative $49,143 and a little bit of change. What that means is that when we discount for the time value of money, ABC Corporation will actually lose money on this investment. They're going to have to outlay $285,000 today to get at what is equal to, in today's dollars, $235,856 worth of money. That's a bad investment. Anytime NPV is negative, you just disregard that investment right then and there. Let's do those same steps for Project C. So we're going to go up to our function bar. We're going to once again take our PV function, and we're going to fill in the information. The required rate of return is our discount rate is still 0.14. Project C has a number of periods of 10, and each payment is equal to $77,000. So we throw those 3 numbers into our inputs, and we hit OK. Again, it's going to come out negative, so let's go and insert a minus sign. And we find out that the present value of cash inflows from Project C is $401,640.90. And for our initial investment, we're going to hit equals, and we're going to go click on that, which is $395,000. So the net present value of Project C is equal to this $401,000 in change minus $395,000. That has a net present value of $6,640.90. Which brings us to Project A. And I wish Project A was this easy. Unfortunately, it is not. So what we can do here to make Project A easier is over on the side, let's create some columns. We're going to have one column called year. We're going to have one column called inflow. And we're going to have one column called PV, present value. So Project A has a life of 6 years. So let's fill in that information. I don't know why that came out to be a dollar sign. We'll get rid of that. Hold on. There we go. And we can fill in with our fill handle the rest of this information. 6 years. So we'll scroll down until it says 6, and there they all are. In year 1, our inflow is equal to this $262,000. We can go click on that. If we fill handle here, it's going to fill in all the numbers from underneath, which it did. Now we can figure out what our present value is. So what we can do here to figure this out is we can go in here, we can go to our function, and we can use the PV thing one more time. The rate is still going to be 0.14. For the first year, the number of periods that we have to wait is 1 year. It's equal to year. And we don't have a payment this time. We have a future value of $262,000. So we're going to hit OK there. And it's going to be $229,824.56. Again, let's go and insert our negative sign one more time. Make it a positive number. Okay, for year 2, we're going to go to f of x. We're going to go back to our PV function. The rate is still 0.14. The number of periods this time is going to be 2 years, because we have to wait 2 years to get that money. But when we do, that money is going to be our future value of $254,000, the amount of inflow for that year. And we're going to come up with $195,444.75. Go put the negative sign in there. Year 3, back to our present value function, and we're going to come up with a rate of 0.14. Number of periods is 3 this time for the year, and our future value for that year is going to be $222,000. Hit OK. Go in and throw in our negative sign, and it has a future value or present value of $149,843.68. We're getting there. Present value one more time. Rate is still 0.14. The number of periods now is 4. And our future value is going to be this $215,000 that we have over here. We can fill that in. Hit negative. For year 5, we're going to go back to the present value function. We're going to have a rate of 0.14. We're going to have the number of periods this time being 5, because it's year 5, and our future value is going to be equal to year 5's cash inflows of $200,000. We hit enter. And one last time for year 6, we hit the present value function. We hit OK. Our rate is going to be 0.14. Our NPER, this is 6 years in the future, and the amount of cash we're going to get in the future is that $175,000. We click on that, we hit OK, and we negate that. So we have our present value of each individual cash inflow that we have. Well, to figure out the present value of all of them, we just take the sum of all of those numbers that we just found, and we hit enter. Our initial investment in this case was $910,000. We bring that down, and our net present value is going to be our present value of cash inflows minus our initial investment. Now we're going to come up with negative $23,988. And let's make that right just so it looks bad. Okay. So if we invest in Project A, we're going to lose $23,988 when we take into consideration the time value of money. If we invest in Project B, we're going to lose $49,143, and in Project C, we're going to make $6,640. Obviously, the only project that's worthwhile to invest in is Project C, because the first two are negative. But to be honest with you, all of these are terrible. But if it has a positive NPV, and you don't have any better alternative, it's better than doing nothing. So in this case, if this is ABC Corporation's only 3 potential investments, they're going to invest in just Project C. Through that 2 methods, last thing you have on your test is going to be your Flex Budget Performance Report, which I'm going to get to in the next video.